Today we start angles and radian measure, moving into some right triangle trigonometry, but it's important at this level of math to understand exactly what an angle is. An angle is formed by the rotation of a ray from an initial point to a terminal point. And so what that looks like is if I have ray AB as my initial side, and I rotate this ray about point A a certain number of degrees, then it's going to have a terminal side. We'll call it C. And the angle between the initial side and the terminal side, we denote with this little symbol. It's called a theta. And it's just kind of like your standard variable for representing an angle. So here, point A is the vertex of my angle, and the angle between the two rays is theta. Now, an angle in standard position has two properties. The first of which, your vertex must be at the origin of the coordinate plane, and your initial side must be on the x-axis. So what that looks like if we draw a little mini coordinate plane in here. So here's my x and here's my y. In order to be in standard position, my vertex must be at the origin. My initial side must be on the x-axis, and my terminal side can be anywhere else in the coordinate plane. If I move in the counterclockwise direction, then that's going to produce a positive angle. It's backwards from what you would think. You are programmed to think that clockwise is positive. But mathematically and in physics, counterclockwise is your positive rotation. So my terminal side is where my angle ends, and theta is the angle between them. If I move in the counterclockwise direction, then that is going to produce a negative angle. When you are working with angles in standard position, you'll often be asked to identify which quadrant the angle's terminal side falls in. And so you have to remember your quadrants. This is quadrant 1, 2, 3, and 4. And the total degree rotation around the origin makes a circle. So it's going to total 360 degrees. If you're in quadrant 1, then you are positive 0 to 90 degrees. If you're in quadrant 2, then you are positive 90 to 180 degrees. If you're in quadrant 3, then you are positive 180 to 270 degrees. And if you're in quadrant 4, then you are positive 270 to 360 degrees. Now, all of these will take on a negative value if you're moving in the negative direction. So quadrant 4 would be negative 0 to negative 90. And quadrant 3 would be negative 90 to negative 180. We have three ways in which we measure angles. The first of which you are the most familiar with, and it is the most common. So we can measure in degrees, which you're very familiar with, you're very accustomed to. We know that if we have an angle that is less than 90 degrees, then that's acute. If it's greater than 90 degrees, then that's obtuse. We have complementary angles. And they add to 90. and we have supplementary angles that add to 180. In addition to measuring in degrees, you also can measure in what we refer to as degrees, minutes, seconds, or DMS for short. So degrees, minutes, seconds. And this measurement comes from, if you envision a clock, then around your circle here becomes the rotation around the clock. And so a total rotation around the clock is 1 hour. So you'll often see this abbreviated as DMS. And so the way this works is 1 minute will be written as 1 with an apostrophe. And 1 second will be written as 1 with a double apostrophe. And it is equivalent to 1 over 60 degrees, because there are 60 minutes in an hour. And the second is equivalent to 1 over 3,600 degrees, because there are 3,600 seconds in an hour. So to convert, for example, if I told you to convert 31 degrees, 47 minutes, and 12 seconds to degrees, and out of its DMS representation, then I would take my 31 degrees, which just stays at 31 degrees, and I take my 47 minutes and I multiply it by the ratio of 1 over 60, and then I add my seconds and I multiply them by the ratio of 1 over 3,600. And when I multiply and add everything together, then this is going to give me a decimal equivalent degree measure, which is approximately 31.787 degrees. And another very popular method for representing degree or angle measures is using radian measures. So a radian is essentially a fractional revolution around the circle, but that's not anywhere near as important as knowing the conversions. So if you convert from radians to degrees, then you're going to take your radian measure and multiply it by 180 over pi, and that will give you your degree measure. If you want to convert from degrees to radians, then you take your degree measure and you multiply by pi over 180, and that will give you your radian measure.